9.1, this is part A. We're going to look at the sides of a triangle, and we're going to also talk about the 6 trig functions that you can get from this triangle. First of all, whenever you see this symbol here, that is going to equal theta. And usually this is going to be your angle, whatever that is. Let's talk about if theta was located right here, meaning the book gave you an angle right here. This side that is the opposite of it is called the opposite side. And this side that is closest to it, the leg, would be your adjacent side. And this will always be your hypotenuse. Now, it's going to be different if you had a theta right here. The opposite side would be this one, and the adjacent would be this one. So keep in mind that it kind of changes. So the 6 trig functions that we can come up with is sine, cosine, tangent, cosecant, secant, and cotangent. The sine is always going to look like this in your book. And it's always opposite over hypotenuse. Cosine will always look like this, and cosine is adjacent over hypotenuse. Tangent will be opposite over adjacent. Cosecant is the opposite of sine. So we're going to flip these two. And first, let's go ahead and put the abbreviation for it. So if it's the opposite of sine, it's going to be the hypotenuse over opposite. The secant is the opposite of cosine. So first we're going to abbreviate this, and it's going to be hypotenuse over adjacent. Cotangent is the opposite of tangent, and again that is also the reverse of it. So it's going to be adjacent over opposite. Now, this is a lot to remember. So there's a way to remember this a little easier. And we use the phrase SOHCAHTOA. I don't know if you've ever heard of this, but this stands for sine, which is, and you can fill this in, and this would be opposite over hypotenuse. C stands for cosine, adjacent over hypotenuse. Tangent stands for T. I forgot to put cosine here. Tangent, which is opposite over adjacent. And if you can remember that the other 3 are the opposites of sine, cosine, and tangent, you'll have no problem with just flipping them over. Alright, so now that we know those, we're going to evaluate the 6 trig functions of the angle. And what I need you to do is fill in this information. This would be coming from the book. Okay, so we're given the 2 legs, and we're given where theta is. And it says we need to find the 6 trig functions. A lot of those 6 trig functions involve the hypotenuse. And you notice that we don't have it. But because this is a right triangle, we can find the hypotenuse by doing a squared plus b squared equals c squared. So 25 plus 144 equals our c squared. And when you add those together, you get 169. and you have to take the square root, which is 13. So now we have our other missing side. Once you have all three sides of the triangle, you're ready to do your trig functions. So if we start with the sine, remember it's SOHCAHTOA. So sine of theta equals opposite over hypotenuse. Opposite over hypotenuse, which is 13. Okay, now we're going to do the cosine, which is CA, adjacent over hypotenuse. So cosine of theta would be the adjacent, which is 5, over hypotenuse, which is 13. Now the tangent of theta is, TOA is opposite over adjacent. So opposite would be 12 over adjacent, which would be 5. So when we do the three trig functions, we can easily do the other trig functions. So if we do the cosecant, we're going to flip this, 13 over 12. And if we do the secant, we flip it, which would be 13 over 5. And if we do the cotangent, we just flip it. Which is 5 over 12. And I'm not sure why I spelled these out, but it should be just the abbreviation. And then you're done. All right, the last problem that we're going to go over is not in your notes, but you should copy this down so you can do this in your homework. They're going to give you what the sine of theta is. So it's 5 over 6. And what we're trying to do is find the other trigonomic functions of this. So if we draw this triangle, remember that sine is opposite over hypotenuse. So the opposite of theta is 5, and the hypotenuse is 6. So we could really put theta only right here, because the opposite is right here. And now what we need to do is figure out what that other side is by doing a squared plus b squared equals c squared. And if we solve for a squared, we get 11. And then we just have to simplify this. So a would be the square root of 11. And we're going to keep it that way so that we don't have to deal with long decimals. Okay, so now that we have all sides, we can do the cosine. Remember, this is CA, so AH adjacent, which is the square root of 11, over the hypotenuse. And now we can do tangent. TOA means opposite over adjacent, so the opposite would be 5 over the adjacent. Now, when you notice there's a square root on the bottom, we have to rationalize this. So that just means we're going to multiply bottom and top by that square root. And the bottom will just become a solid 11. So this is really tangent. All right, now the other three will be very easy. So we have the opposite of sine, which is cosecant. So we're going to flip the 5 over 6, so it'd be 6 over 5. The secant, which is the opposite of cosine, is the 6 over square root of 11. And again, we have to rationalize this. So we have 6 square root of 11 over 11 for secant. And then we have the opposite of tangent, which is cotangent. And remember, you're going to look at the original. So 5 is on the bottom, and the square root of 11 is on top. And that is it.